Hey guys, thought it might be helpful to do a review on antigen presentation, the differences between MHC2 and MHC1. There's quite a few differences. We'll talk about the cells that are involved and other structures. So first, with an MHC2 molecule, a bacteria is presented to usually a dendritic cell. That dendritic cell will take it in through phagocytosis. When it takes it in through phagocytosis, it will take a bit of the membrane with it and create a phagosome. That's what will then transport that bacteria to the lysosome, where the important processes of creating epitopes will occur. Now, originally, on the bacteria cell walls, there were antigens, little antigen pieces that were used to identify it in the first place. And what the lysosome does is it's going to take that bacteria, chop it up, and then create from those little antigens a protein antigen epitope that can be picked up by the MHC2 that the lysosome also helps to activate, and that will then be taken to the membrane of the cell. Once at the membrane of the bacteria, that epitope can then signal for a T cell. It's important to note as well that this expression of MHC1 and these epitopes are only going to be the most antigenic and most immunodominant epitopes that are going to appear. Then in an MHC1, what happens is we usually are using MHC1 so that the NK cells don't come about and kill us. And how does this happen? There's a protease, or the proteasome, that gobbles up any proteins that are hanging out within the cytoplasm and does the same thing as the lysosome pretty much did, where it creates an epitope that then this MHC1 molecule can pick up, take to the cell membrane, and say to the NK cell, "We're healthy, don't kill us." Now, if something were to go wrong, so if something goes wrong in an MHC1 cell, these normal nucleated cells, let's say like a virus, attacks, replicates, gets these different proteins within the cytoplasm, the proteasomes don't care. They're just chopping up whatever proteins are hanging out in the cytoplasm, and so it degrades the proteins of, say, this virus and turns those into epitopes that are then taken to the membrane by an MHC1 molecule. But the issue here is that we need the APCs in order to activate the T cells to come across and actually do anything to this cell. So despite this signal now being there, there's no T cells activated to come over and kill it. So the next thing we need to do is activate the APCs. Now, the APCs can be activated in a couple ways. First, if a virus were to attack an APC, then it just already has that epitope within the cell that when the MHC1 expresses it, then it's good to go. It'll activate T cells. But if a normal cell is infected, it does not activate a T cell. We need the APCs, especially dendrites, in order to activate T cells. So what happens is there's some free-floating antigens, and the dendrite is going to scoop that up and use an MHC1 to then express the epitope to the cell membrane, and now the T cell can recognize it. Once the T cell has recognized it, then it can go back. Now all the cells that have that epitope can be detected and killed. The end.